Welcome back to part 4 of our series, Introduction to OBD2 and Electronic Vehicle Diagnostics. So far, we've explored the basics of vehicle diagnostics and the tools we used, and OBD2 system itself. Now it's time to get into the heart of how the vehicle actually knows something's wrong. Modern vehicles are packed with sensors and actuators, constantly measuring and adjusting, and feeding data back to the vehicle's electronic control units. Understanding how faults are detected gives you the insight you need to separate a real issue from a false alarm.
We will generally discuss the basic petrol internal combustion engine. The petrol engine operation is based on the Otto cycle: induction, compression, ignition, exhaust. Induction is dependent on the air-fuel mixture, compression mainly on valve timing, ignition on spark timing, and exhaust once again on valve timing. Compression and exhaust are dependent on valve timing. Valve timing is controlled mostly by mechanical processes. On older vehicles, the air-fuel mixture is controlled by a carburetor. On new vehicles, the air-fuel mixture is controlled by the electronic control unit of the engine. Spark timing on older vehicles was controlled by the mechanical distributor and coil, while on new vehicles, once again, it's controlled by the electronic control unit and coil packs. Older systems use open-loop control. Modern systems make use of closed-loop control. We will now go through the definition of control loops. With a carburetor, the air-fuel ratio is set by the jets. These add a given amount of fuel for a given airflow. This is the same for first-generation fuel injection. This is called open-loop control because the system has no feedback of the actual final air-fuel ratio. Closed-loop control is exercised when an exhaust gas analyzer is used to measure the exhaust output and then adjust the carburetor jettings to perfect the air-fuel ratio. This is the same as with first-generation fuel injection. Closed-loop control in modern engines is achieved by the use of oxygen sensors, which measure exhaust gases and then adjust the fueling in real time. Sensors detect activity, similar to our own sensory organs: sight, hearing, taste, feel, and smell. In vehicles, examples are oxygen. Actuators create motion or activity, like our muscles, or a window actuator or fuel pump in a vehicle. How faults are detected. Faults are detected by the vehicle's electronic control units, which monitor the sensor and actuator signals. These signals should conform to specified values and criteria, for example voltage or frequency. If the signals do not conform to expected values, then the control unit will assume there's a fault. Control units have onboard monitoring and diagnostic processes, which enable the control unit to measure or detect electrical values in the circuits and monitor the responses of actuators when a control signal is changed. In order to detect if the electrical values in circuits are correct or incorrect, the control unit will have the correct values stored in its memory. The same way one would use a multimeter to measure an impedance and compare it with the value in a spec sheet. Electrical circuit check, system performance check, or logic. The monitoring of signals is the root of fault detection. The control unit monitors signals to ensure that they are within a specified range or pattern for each type of signal. If the signal goes outside this range, the control unit will generate a fault code. Probably the simplest signal is a voltage that is either on or off. The signal can be produced by a limit switch, which switches off or on when the device reaches a specific position, like on an electric window, for example. This is an example of a signal where the voltage changes, like a temperature sensor. In this example, the normal operating range for the temperature sensor is between 0.3 and 4.7 volts. If the voltage is outside of this range, above or below the range limits, it will be regarded as a fault. Note that different systems will have different voltage ranges. The signal change can also be a varying frequency signal, digital or analog, like a hot film MAF sensor.